So I'm going to explain to you guys the energy systems the way I share them with clients so that they understand what the frick is going on. So this is going to be what we call layman's terms on the energy systems, and this is probably going to be, in my guesstimation, this is going to be the easiest way for you guys to identify what's going on and be able to explain it. And then we'll go a little bit further in depth with the science and the terminology. But what I want to do is just explain to you the very quick way to know and identify, okay, this is what energy system that they're in. Capiche? Okay, I'll come back to this in just a second, because that's the reason why I posted it, is to talk about this right here. Let me enlarge this a little bit if I can without losing the pictures. Okay, this right here is, you see right here, we've got ATP, we've got ATP plus PC, we've got ATP plus PC plus lactic acid, and then we've got electron transport and oxidative phosphorylation. Now I want you to memorize all those terms and never forget them. Sound easy? Wasn't for me. Okay, so what I tell the client is our first energy system is stored sugar. How many of you guys have been on a sugar high before? It's great, huh? You're running, you're jumping off the walls, you're climbing on the ceiling, you're going cray-cray, right? Got lots of energy, boom, right? So that's what I tell people these first two energy systems, or basically this one energy system, is like. So I say that we want to use your stored sugar first, okay? And then we go to the lactic acid energy system. Have any of you guys ever done a workout where you're feeling the burn? Oh my gosh, I feel like my legs are gonna die, right? I'm breathing so heavy, I'm sucking back wind, I'm looking at my lungs come out and into my mouth, you know. Just asking a person to run around the track one lap as fast as they can, they're gonna feel that burn, right? So I call that, and it's easily associated mentally, you say lactic acid. You put the word acid with this energy system and people identify what that feels like. Okay, so I call that lactic acid. Okay, and then you've got your aerobic. Everybody knows what aerobic is, right? That's when you've been doing anything for a prolonged period of time, your heart rate's elevated, you're breathing heavy, okay? You're in the zone of cardio. There's your aerobic energy system. Okay, so we got these three systems: stored sugar, lactic acid, and aerobic or cardio, right? Now, all of these systems are functioning all of the time. But depending on what activity you do when you're exercising, one is going to be more dominant than the other. Your aerobic energy system, you've got it. It's kind of like when you're driving a car. Do you start off in 5th gear when you're driving a standard? How many of you guys know how to drive stick?
I'm good with.
Man, oh man. Wait, you guys all drive self-driving cars now?
I heard sticks are way harder, though.
It'll take you like 20 minutes to learn to drive a stick, Catherine. It's super easy.
I don't know where to go from here if you guys don't know how to drive stick. I don't know how to explain this lecture anymore now. Okay. So how many of you guys have pedaled a bicycle that's got more than one gear on it? Just lie to me and say yes. Bicycle with my, okay. So when you start that bicycle, do you start it in high gear? No, it's too hard and heavy to pedal, right? You've got to have something that is easier. And then as soon as you get going faster, you geared to a higher and higher gear that's harder and harder to pedal, but it doesn't feel harder to pedal because you've got momentum going, right? You guys with me on that? Energy systems in your body is very similar to that, right? If you get on the treadmill, and next time you do, pay attention to this. As soon as you just develop this little bit of awareness to it, you'll be able to identify it very quickly, okay? When you get on the treadmill and start running, you're not in the cardio mode or cardio energy system right away. For me, it takes my body about 4 minutes to get into this aerobic oxidative state, okay? And I can tell by the way my breathing changes. I start to breathe heavy, and then I start to level out into a pace, and then I know that I'm in my oxidative cardiovascular zone, okay, or my aerobic zone. Until that 4 minutes goes by, and this is dependent on what kind of intensity that I'm giving in on the treadmill. If I'm going pell-mell like there's a grizzly bear chasing me on that treadmill, right, and I've got that thing up to 7.5, you know, like those people in the gym, you all hear them, right? Thump, 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 thump on the treadmill, right? Yeah, they're gonna go into their aerobic zone much, much quicker, okay? So this depends on the type of output that you're giving, right? But for me, if I get on the treadmill, I'm gonna do a cardio session, get on, and I start running, boom, boom, boom. It takes me about 4 minutes to get in there. I can feel when it happens. Start to breathe heavy, and then I start to get into a groove, and then I start to pace myself where I can intrinsically feel like, oh, if I go at this level, I'm good to go. Okay, if I go at this intensity or give this much effort, I feel like I could sustain that for a while. So I'm starting to pace myself. There I'm in my aerobic zone. Until I get to that point, in that 4 minute mark approximately, I'm using this energy system, this stored sugar, and I'm using my lactic acid energy system, okay? Once those cannot compete for the demand or they're struggling to produce the energy fast enough, okay, my aerobic, and they can't compete with it, my aerobic energy system is going to jump in. So these, they basically have a time limit. When you use up all the ability that they have to use to produce energy, or they cannot produce the energy fast enough, then you end up gearing down into this aerobic energy system. Okay, so you've got 3 energy systems. Okay, so that's my easy way of explaining it and how I tell my clients. Okay, now if I was weight training, and this is important, thumbs up, you guys with me on this? If I was weight training, would I want to use my aerobic energy system, my lactic acid system, or my stored sugar energy system? What do you think?
Stored sugar?
Stored sugar, sure.
Yeah. If I'm having a bet with my friends on how much we can back squat, and the person who loses is buying, right? I want my stored sugar. In fact, I'm going to go to my locker and I'm going to down a goo or whatever. I don't know, whatever. You could take some stored sugar, right? I know when I was doing track and field, people would take spoonfuls of honey and stuff, and my mom would see that and she's like, oh, that's so bad for you. She was wrong. That is actually really, really excellent for performance. But anyway, you want to use that stored sugar, okay, when you do weight training. How many of you guys have seen people go into the gym and do their cardio training session first and then go to the weights? It's classic. It's classic. So let's say I take Jeff out to the track and I have him run 1.5 miles. I have him do the 1.5 mile test, where he's running 6 laps around the track as fast as his legs can carry him. He crosses that finish line and his lungs are splattered all over the ground. He's barely not able to catch his breath. He's done. He's just completely, he left it all on the track. He's wasted. I give him 5 minutes to catch his breath, and then I say, okay, Jeff, we got heavy legs today. We're gonna go over here and we're gonna put in 3 rep max on our back squats. We're gonna be lifting at about 87 to 90% on our back squats today. Ready for this?
You gonna watch Jeff die then?
Exactly, because Jeff just completely torched his stored sugar and his lactic acid system and went smashing pell-mell into that aerobic energy system. He's got nothing left in the tank for a good weight training session. Now, this is an exaggeration, okay? But that's essentially what we're doing if we do our cardio training first before we do our weight training.
So you would recommend weight training first instead of
yeah.
So okay, my question to that is that if you would do weight training first, would you go lighter than you usually would and then do the cardio?
Why?
No, you'd smash out what you can in the gym for your weightlifting, and then try to finish off your body with your cardio at the end.
Yeah.
Okay.
A crap ton of cardio.
Well, I just want to know because it's different for everyone, so that's something interesting that I thought.
No, it's not. Believe it or not. I mean, I'm really glad that you're talking through this, Catherine, because this is what everybody's everybody's wondering in the gym, right? These are good questions. So everybody's body, as far as its utilization and production of energy, is the same. Almost. I mean, genetics, like Michael Jordan probably had a little bit more stored sugar than other folks in his calves, which is why he could jump over the moon and back, right? So there's a little bit of genetics involved in the amount of energy production that your body's going to be able to produce. But the systems and the way they operate are all the same for everybody, is what I'm trying to say. So if you go into a strength training session after you do cardio, it is very difficult to, I would almost say that you cannot hit as effective and efficiently the results that you're trying to hit weight training if you do your cardio first, because you're not strong enough. You've gone and fatigued that muscle to the point where it's going to underperform what you expect. And the only real way that you can understand this is if you lift heavy shit in the gym. Excuse my French. Hope there's no kids there, but I'm swearing for emphasis here. Because most dudes go into the gym and they put 225 on the bar and go through back squat, and they're like, oh my gosh, 225, I'm doing 5 reps at back squat, that's going to kill me. Just thinking about it makes my palms sweat. But their 1 rep max is 315. And they're doing 225 for 5. It's not heavy enough to get results. They need to put, 265 on the bar. It almost feels exactly the same as doing 5 reps at 225, doing 5 reps at 265. I mean, it's still a cruel world, but neurologically, it makes the world of difference. And if you ask somebody to, instead of doing 225 after a cardio session, to put 265 on the bar, they're going to say, hell no. They're not going to be able to do that. Okay, so most people, they don't track the data, so they don't know what numbers they should be lifting in the gym. Okay, and those are people that, where's my phone, that don't take their program with them so that they can check when they're lifting. And they do their cardio first. If they're trying to get strength results, okay, don't do your cardio first. It's like trying to paddle a canoe upstream, upriver, against what your body's natural tendency is to do. Okay? So if you're doing strength training, you do that first. Now, the reason why most people do their cardio stuff is because they feel like they really need to warm up before they go super intense. Well, that's part of, activation, mobility, and movement prep. So you do a little bit of a warm up, but man, if you can't get your client activated in under 2 minutes, you need to come talk to me and we'll go through the lecture, because all you need to do is have them jump rope and boom, they're activated in like 30 seconds, right? It doesn't take long to get the heart rate elevated. So do some burpees, do some jump rope, do a few box step ups, do some jumping jacks, some skiers, whatever. It could be jump on the treadmill and jog, and then they're kind of easing into it a little bit more, but get them activated. And then once they're warmed up, then go and hit the weights. Okay. Now, movement prep is the back end of your warm up. So if I was to take Anthony into the gym and we were going to do back squat, and I just had him warm up on the treadmill for a little bit, and then I say, okay, Anthony, here we go. Our 1 rep max is 315. We're going to put 300 on the bar. I'm going to have you do 1 rep of that. Go ahead and load it up and squat. Do people do that? No. What you mostly see them do is they'll grab the bar. They'll go through a back squat with an empty bar. Then they'll put maybe a couple plates on the side, just some light stuff. Boom. All right, there I'm getting, and then they're going to start to build up heavier with a few more reps. So they put in a couple warm-up sets of just practicing the movement. That's why we call it movement prep. So that is within the workout, not at the beginning of the workout. If you're going to bench press, people bench the bar first. Get a little bit of warm up on the bar before they put 225 on it. Make sense? Okay. Now let's talk a little bit more about the details here. And again, we've got some time on the back end of this to go into a little bit more detail with the energy systems. And hint, some of the reasons why I go into more and more detail of this in the second class is because you guys are getting exposed to this and you're like, oh crap, I'm going to read about this a little bit more if you haven't already. This is in your ACSM textbook. There's about 2 pages that goes into this, okay? So the terminology for this is we've got our phosphagen system, glycolysis, okay, or glycolytic. They have different names, but sometimes people will use different terminology, but it means the same thing. And then you have your oxidative energy system, okay? So give me a thumbs up if you're paying attention to this. This might put you to sleep, but I hope not. Hopefully, I'm not going to put you to sleep. But it's, thank you. So it's all about the phosphate when we're talking about producing energy, okay? So we've got this phosphate system, but they pronounce it phosphagen. Phosphate, okay? In fact, let me back up just a step. I kind of jumped ahead a little bit too far ahead. 3 energy systems in muscle cells to replenish ATP. This is definitely a word that you want to know as a trainer, what ATP stands for, and that's adenosine triphosphate. There's 3 phosphates in adenosine triphosphate. Where's my picture? Adenosine triphosphate. Oh, come on. It's up. Here we go. So here's adenosine triphosphate. We've got 3 phosphates. We've got a ribose and we've got an adenosine right here. This is part of the molecule, but every living thing uses adenosine triphosphate to create energy or to produce energy, okay? And what happens is this one phosphate gets broken off of this. It's kind of like maybe, when we're talking about nuclear power, when that atom splits, right? Okay. When we're talking about electrons and all that stuff splitting off in these atoms and everything else, right? It's kind of like that. When this phosphate breaks off of this molecule, there's a tremendous amount of energy that's released. And everything that we do metabolically is all about getting to that point where we've got ATP created and we're breaking off that phosphate to produce energy. Now, when we do that, see right here, we've got ATP, right here, adenosine triphosphate, and right here, this phosphate breaks off and energy is released. Think of like an explosion, okay? So the first one that we have, so there's 3 energy systems, the phosphagen system, glycolysis, and then oxidative. So we've got a certain amount of ATP that's stored in our muscle cells. That's good. The sucky part of it is it's in micro amounts. Like, it's pathetically low. It just sucks. You've got enough ATP stored in your muscle cells to maybe jump up and down 3 times, and then it's done, depending on your level of intensity and exertion. Okay, so your ATP, you've got a stored amount, and then it's done. So you got 3 to 4 seconds. Can we perform exercise at a high intensity for more than 3 to 4 seconds? Oh yeah, definitely. Well, why? Well, because we've got stored creatine also in our muscle cells, and it is almost immediately donating a phosphate to adenosine now diphosphate because it lost that phosphate. So creatine comes in and throws in another phosphate to that group. So how many of you guys have heard of, oh yeah, dude, I take creatine monohydrate, man, it helps me with my lift, right? That's the creatine that we're talking about. But when we're talking about it in the muscle cell, it's not creatine monohydrate, it's creatine phosphate. It's all about the phosphate, okay? So that thing breaks apart, and so ATP is broken apart, explosion of energy, good to go, only lasts about 3 to 4 seconds, depending on your level of exertion. Okay, and that creatine phosphate donates a phosphate to that ATP, or sorry, ADP, adenosine diphosphate, and replenishes. I think we've got so this phosphate is being donated. Okay, so ATP is being replenished, and it's all about getting back that extra phosphate at the end of the molecule. Now we have, and this is in your ACSM textbook, I believe, your phosphocreatine system right here will give you about 10 seconds of energy. So that's combined, so your ATP storage and your storage of creatine that immediately goes and repairs that ADP back into ATP, gives you energy almost immediately, okay? That gives you approximately 8 to 12 seconds of energy. Now give me a thumbs up if you're listening to this point, because it's important, okay? When we do a lift in strength and resistance training, how many reps do we recommend the average client to do, or the general population to do?
8 to 12.
Yeah, 8 to 12. How much time do we have in our phosphagen system, our phosphocreatine system?
8 to 12.
8 to 12. My gosh. Interesting, huh? So we're utilizing that phosphagen system when we lift, and it usually corresponds, oh, I'm going deep on you now, time under tension. How long is the muscle under tension for? So there's a little bit of break in between going up and down, right, where the muscle's not really working. When we're going down on that eccentric phase, the muscle's much stronger on eccentric than it is on concentric, so it's getting a little bit of a rest, right? But the concentric phase, we're looking at time under tension there for approximately 8 to 12 seconds. Okay. Now, what happens is we start to bleed lactate into the cell. Once we've used up all that 8 to 10 seconds, so, and by the way, this is all anaerobic. Anaerobic means no oxygen. If you put an A on something, it usually means against or opposite of in scientific terminology. So anaerobic. Aerobic, anaerobic, without oxygen. Okay, this is all happening in your muscle cells with no oxygen. So I could ask Usain Bolt to go and run the 100 meters, and how long does it take him to run 100 meters? Like 3 seconds or something like that? I should call him Insane Bolt. Anyway, so Usain Bolt does the 100 meters. You know, those 100-meter athletes could run the 100 meters with their head chopped off, or basically their mouth and nose completely covered. They do not need oxygen to run that race. Once they cross the finish line and they're resting, there's an oxygen debt. Oh, you better believe they're going to be sucking in wind. But during that race, it's all anaerobic. Okay. Now, when we get into the phosphocreatine right here, we're talking about the body's ability to take lactate and resynthesize it back so that ATP is being replenished with that phosphate again via the fast glytic energy system. Okay, and we'll talk about that a little bit more in depth. And it's also, if you take a look in your ACSM textbook or this Google document all the way down here, we're talking about anaerobic glycolysis, and you can read about that. And then they're talking about aerobic energy system, and we'll talk a little bit more about that when we get into class next week. Okay, helpful, you guys?
Yes, sir.
Okay. I would love for you guys to read this stuff. It's only like 2.5 pages of your ACSM textbook. Or if you go to the Google document, I just snipped it and put it in here. Okay, you can read about that. The aerobic system is much more complex. There's a lot more moving parts. It is the most efficient energy producer, but it's complex and it's pitifully slow, very slow, but the most efficient. So there's more moving parts in here. So you're going to learn hear about things like electron transport chain, citric acid cycle, or otherwise known as Krebs cycle, which will give you a headache. Now, give me a thumbs up if you're paying attention to this. This is the last thing I'll say before. I'm just kind of putting some stuff in here to get you guys interested. How many of you guys like nutrition? Pretty cool stuff, right? How many of you guys have heard about B vitamins before? Awesome, right? Those B vitamins are what we're talking about with this citric acid cycle right here. Acetyl coenzyme A, nicotine adenine dinucleotide. We're talking, those are B vitamins. They're just named different. I don't know why. But you're looking at all of these different NADH, NAD, FAD, all these different things. This is happening inside the cell, and it is you're looking at your B vitamins at work. So when they say B vitamins give you energy and make you happy, this is happening at a cellular level. Okay, this is B vitamins. So go look them up. You can Google B vitamins in the cell, blah, blah, blah. It's pretty cool. So I'm just kind of trying to tease you into studying some of this stuff. It's really interesting when you get into it. All right, guys. Sorry I went over time. We will see you guys next week. Thanks for being in live class.